What we're getting into now is section 10.1, and what we look at in section 10.1 is the right triangle trig functions, the basic right triangle trig functions, which are the building blocks of trigonometry. But it's not really trigonometry like you'll take in a couple of years. It's just the very basics that we always look at in geometry, so it is part of geometry course, and always has been. And what these are basically sine, cosine, and tangent. But what they're based on is just side lengths of a right triangle. So the first thing we're going to look at is in a right triangle, we always have, and sorry about that part, we always have a right angle. And the side across from the right angle, if I go straight across from here, is always the hypotenuse. Okay, so that's my hypotenuse. And then what we're going to do is we're going to label the other two sides with some names that help us to describe our ratios. But before we can do that, we need to know which angle we're looking at things from. When we look at these, the right triangle trig functions, we always look at them from the standpoint of either this angle over here or this angle up here. In other words, one of the two acute angles of the right triangle. We won't ever look at things from the right angle. We'll look at things from this acute angle or this acute angle. So let's say that my triangle is called triangle PQR. Then when we identify these other sides, we're going to identify them either from standing at P or from standing at Q. It's kind of like if I'm standing someplace and you say, hey, look at the wall across from you. Well, it depends on where I'm standing in terms of which wall is across from me. So that works the same way here. If I'm looking at things from the angle of P, then I would call side PR my adjacent side. Adjacent means next to. Okay, so this side is next to P, so I would say this is the adjacent side. Notice that this side up here is also, PQ is also next to P, but it already has a special name of its own. It's the hypotenuse. So when I say the adjacent, I'm talking about the leg of the right triangle that's next to the angle I'm working from. Then the other side, the side that's not next to P, the one that's all the way across on the other side of the triangle, I call the opposite side. So whenever we look at a right triangle and we're thinking about right triangle trig, we will always start out by figuring out where's the hypotenuse, which angle are we working from, and based on that, which side would be the adjacent and which side would be the opposite. If I wasn't working from angle P, if I was working from angle Q, things would be different. Just like if I'm facing one wall and I say the wall across from me, and then I turn and I face a different wall, then the wall across from me is a different wall. So let's look at things just from looking at angle P right here. We have three right triangle trig functions. There's the sine ratio, and that's SINE. There's the cosine ratio, COSINE, and there's the tangent ratio, TANGENT. And remember, ratio means basically fraction. Okay, so it's a relationship between two numbers. So we're going to talk ratios of side lengths, like maybe this length over this length, or this length over this length, or this length over this length. So we're going to be talking about a ratio of the different sides of the right triangle. Now, even though we spell sine S-I-N-E, most of the time when we write it, we're going to abbreviate it, and it's going to be S-I-N. That's the abbreviation. We use three-letter abbreviations for these. That doesn't mean we say it's sin. It still stands for sine, so we still pronounce it sine. And same thing for cosine. When we abbreviate it, we still say cosine. When we abbreviate the tangent, we still say tangent. All right, so here's how things work with these. These are really what you would call the definitions of these ratios, because it explains what two sides we're doing a ratio between to get each one of these. The sine ratio is the ratio of the opposite side over the hypotenuse. And really, when I wrote this, I probably should put sine of P. We always are talking about from a certain angle. If you don't write it, that's fine for right now. But for sine, we're talking about a sine of a certain angle would be the opposite side over the hypotenuse for that angle. So in other words, if I say the sine of angle P, I'm talking about this side over this side, RQ over PQ. If I'm talking about cosine of angle P, then I'm talking about adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. Now I put the P's in there just to remind you that it's always from a certain angle. It could be sine of Q, cosine of Q, tangent of Q. These definitions don't change for different angles. No matter which angle you're looking at things from, the sine of an angle is always the opposite over the hypotenuse. The cosine of any angle is the adjacent side over the hypotenuse. And the tangent of any angle is the opposite side over the adjacent side. So when we try to remember this, because we have to remember this is something that you would not be given formulas for, because the ratios are what you need to know. You need to know which ratio the sine ratio is. In other words, it's the ratio of this side, the opposite side, over this side, the hypotenuse. Okay, because you need to know this, and you need to know this, and you need to know this, we have a little mnemonic device, that means a memory aid, that we use to remember that the sine is the opposite of the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And that's SOHCAHTOA. SOHCAHTOA is really kind of the universal way of remembering this, as in people from all different schools would know what you mean if you say SOHCAHTOA once they've learned about right triangle trig. And what that stands for is the first letters. So sine is opposite over hypotenuse. That's the SOH. Cosine, C, is adjacent A over hypotenuse, H. CAH, cosine is adjacent over hypotenuse. And TOA is tangent, is the ratio of the opposite side over the adjacent side, TOA, TOA. So when we say SOHCAHTOA, we're just reminding ourselves of these facts, that this is what the sine is, this is what the cosine is, and this is what the tangent is. Now, some people will take it a step further and use another memory aid, another mnemonic device, to remember this mnemonic device. But since the only thing we're doing with this is trying to remember this, it seems a little ridiculous to me to try and remember something else, to remember this, to remember this. Because then you're trying to remember more things to help you remember than you actually even need to know. But if that helps you, if you have trouble remembering SOHCAHTOA, which one way of remembering it is just to use it and say it a lot, you'll have heard SOHCAHTOA a lot by the time we finish going over this. There are stories. There's a story about like the brave Indian chief SOHCAHTOA. There's a story to help you remember. A lot of people put the letters together to form a sentence acronym, like a sentence with the same starting letters. One of the ones I've heard over the years is some old horse caught another horse taking old apples. That one's not that engaging. There's another one that people like a little bit more because it makes them think of something a little bit silly and or a little bit wrong, and that is some old hippie caught another hippie. Actually, I'm sorry, I said it wrong. I thought about the horse one. Some old hippie came a hoppin', trippin' on acid. Some old hippie came a hoppin', trippin' on acid, which is something that the hippies were sometimes known to do. So, of course, that's not endorsing acid in any way, but just meant to give you a mental picture of a funny hippie walking along, stumbling along perhaps, came a hoppin', trippin' on acid. However you remember this, the idea is that this helps you remember this. Now what this means, in other words, is if I take a right triangle, let's say I have a right triangle with one of those great Pythagorean triples that you guys were looking at the other day, which I got some good examples of on your quiz. Here's a Pythagorean triple. Okay, let's call this triangle A, B, C. If I want to know what the sine of angle A is, then I would say I need to know the opposite side from angle A, and I need to know the hypotenuse of angle A. The hypotenuse is the 17. Opposite is the one that doesn't touch it, it's over here. Sometimes it's easier to think of the adjacent first, because adjacent means next to. So the 17 is the hypotenuse, the 15 is the adjacent, and the 8 is the opposite. That's all thinking of things from the standpoint of angle A. So for angle A, this is hypotenuse, this is adjacent, this is opposite. So opposite over hypotenuse would be 8 over 17. The cosine of angle A is adjacent over hypotenuse, AH, CAH. That's from SOHCAHTOA, right here. So cosine of angle A is the adjacent one, which is 15, over the hypotenuse, which is 17. And finally, the tangent of angle A is the opposite side, which is 8, over the adjacent side, which is 15. It's just a ratio of side lengths. Sometimes because it's a ratio, we leave it in fraction form. Sometimes you're asked to change it to a decimal, and sometimes you do both. Remember, if you are asked to change a fraction to a decimal, all you do is say 8 divided by 17. That's all you're doing to change the fraction 8/17 to a decimal. This would be 0.47. 15/17 would be 15 divided by 17, 0.88. And 8/15 is 8 divided by 15, and that's 0.53. Notice that I'm rounding to the nearest hundredth. This is also what your book asks you to do. The nearest hundredth means I go 2 numbers after the decimal point, and I round that second number if I need to, only if the third number is 5 or higher. Okay, so what we just did here was we did everything from the standpoint of angle A, which is one of the 2 acute angles in the right triangle. Remember that you don't ever do it from the right angle. Really, it's because it wouldn't make sense from the right angle. Like for instance, the opposite is the hypotenuse, and these would both be adjacent. So it just doesn't make sense for the right angle. So we only do it from the 2 acute angles. So here I just did everything from the standpoint of angle A. Let me also go ahead and go back and do it from the standpoint or the point of view of angle B. If I was asked to do the sine of angle B, sine of angle B, now remember for A, 8 was opposite, and I'm going to go ahead and color coordinate this. For angle A, the opposite was the 8, the 15 was the adjacent, and the 17 is the hypotenuse. Now the hypotenuse doesn't go anywhere depending on where you're standing. It's kind of like with my wall analogy where I say if I'm facing one wall and you say the wall across from you, it might be different if I turn. Either way, the ceiling's still in the same place. The hypotenuse is kind of like the ceiling. If you say the ceiling, I know exactly what you mean. It doesn't depend on which way I'm thinking or which way I'm facing. Same thing goes here. The hypotenuse is always where the hypotenuse belongs, right across from the right angle. Okay, here, if I'm looking at things instead of having an A here, I'm looking at things from B instead. That means I'm like standing right up here. So now the side or the leg that is closest to B, the leg that is right next door to B, is 8. So for B, this would be the adjacent side. For B, this would be the opposite side. And again for B, it's still the hypotenuse. That doesn't change. So for sine of B, I'm doing opposite over hypotenuse. For cosine of b, SOHCAHTOA, adjacent over hypotenuse. And tangent of b, opposite over adjacent. Okay? Now notice that these fractions are ones we've seen before. The sine of b is the same as the cosine of a. That's because when you go from standing at A and looking at things from the perspective of A to looking at things from the perspective of B, well, the opposite and the adjacent trade places. So that would also kind of trade which one's on top. And so whichever one used to be the cosine becomes your sine. So the 15 over 17, these are going to match. The sine of one angle is always the cosine of the other angle. And when I say other angle, I'm talking about the two acute angles only, not the 90. Same thing happens here. The sine of A and the cosine of B, those will also be the same, so I'm just looking back here to find my decimal. Now here, that doesn't work. But those two fractions are still related. Those are reciprocals. If I change which way I'm looking at the opposite and the adjacent, all it does is flip over. So this time I have 15 divided by 8, and I get 1.875, which is 1.88 if I'm rounding to the nearest 100th. Excuse me. Let's do another one like that, a little bit quicker. Let's say I am looking at this triangle, and I'm going to call it MNR. So triangle MNR, let's say that it has side lengths, and I'm using a Pythagorean triple just because it's simple. It's nicer to work with whole numbers. It won't always be whole numbers, but it's nicer to work with them. So let's say that this is excuse me, 6, 8, and 10. Okay? If I'm asked to find the sine ratio or the cosine ratio or the tangent ratio of either one of these angles, and I already know the side lengths, this is just like the one we just did, I'm just putting one of them over the other. It's just a ratio, so I'm putting one on top of the other. I just have to know which one goes on top of the other one. Okay, so if I'm finding the sine of n, looking at the world from the perspective of n means this is adjacent, this is opposite, and this is hypotenuse. So opposite over hypotenuse, like so in SOHCAHTOA, that's going to be 4/5 as a fraction or 0.8 as a decimal. Cosine of n, adjacent over hypotenuse, that's 6 over 10. That's 3/5 as a fraction or 0.6 as a decimal. And the tangent of n, opposite over adjacent, is 8 over 6 or 4/3 as a simplified fraction, which is 1.3 repeating forever. So these are my answers. Now you go ahead and look at things instead of from N, let's come over here to R. Think about where the opposite would be, where the adjacent would be, where the hypotenuse is going to be. The opposite and adjacent basically trade places. Because if I'm standing at R, then 8 is next to me. So this becomes the adjacent. And that means 6 is across from me, so that becomes the opposite. The hypotenuse does not move. It's still the same place. So if I'm looking at the world from R, the sine is opposite over hypotenuse, so the sine of R is 6 over 10, same as this was. 6 over 10, which is 3 over 5, or 0.6. The cosine of r is adjacent over hypotenuse, 8 over 10, just like the sine of n. So 8 over 10, which is 4 over 5, which is 0.8. And the tangent of r is opposite over adjacent, 6 over 8, which is 3 over 4, or 0.75. Okay, so now what you want to do is you want to turn to page 318 in your book. Turn to page 318, and on page 318, look at the first check it out. So in your book, page 318, the first check it out, 1A, 1B, 1C, try those three problems. Try 1A, 1B, 1C on page 318 in your textbook.